Hi there, Alberto Savoia here with you again for lesson 3 in the math of success for product managers. So let's not waste time because there's a lot of meat in this lesson. So remember, my goal is to teach you the basic math so you can be super successful as a product manager, way above any of your peers. If you know these mathematical tools, you will have an unfair advantage over anybody. You will look good, and more importantly, the products that you work on will have a much greater chance of being successful in the market. So with that, let's have a super quick review of what you learned in lesson 1 and lesson 2. So in lesson 1, we learned that your key question that you need to answer as a product manager is, will this new product idea be successful? We've learned that you cannot give a yes or a no answer. There are no guarantees, nor you can give a very specific answer like there's a 73% probability of success. But what you can do is to have 5 buckets of likelihood of success. They go from 0.1 to 0.9. Very unlikely, unlikely, even odds, likely, and very likely. So I've shown you a way to take some qualitative stuff and put it into a quantitative way. So what we want to know is the probability of success for a new product. Then we thought, well, we need to define our terms, right? We're trying to be formal and mathematical here. So we define success. Once again, in a very, very clear way, we define success as follows. Your actual results must be greater than your expected results. So we draw a line in the sand about the minimum requirement for your product. So, but how do we express the expected results? As always, this is math of success. We say it with numbers. And I've given you one of my most precious creation, one that I really love, the XYZ hypothesis. So you can express, in fact, you should express your expected results in the following form. At least X% of Y will do Z. X% is a percentage of the market, Y is your target market, and Z what you expect them to do. So, and I'm going through the review because it will come in handy for this next example. So here's an example of the X% of Y will do Z idea. So I've created, just for the purposes of this class, a make-believe product. So I use a lot of markers. I've been teaching and doing programming and engineering for years. I'm always in front of a whiteboard, and I must have tossed a lot of them away. So the idea that I came up with is, I call this forever marker. The way it works is when the market dries up, you put in water for 30 minutes and it's as good as new and it will last forever. Now, I don't know if it can be built, but it's just an example of the idea. So, but before I invest $10 million to develop the forever market, I have some expectation. So my expectation, I express it like this. At least 20% of whiteboard markers buyers will buy my forever markers for 10 times the price of regular markers by Q4 21. So I expect at least 20 people out of 100 people that buy these markers, they will buy my marker. So what I want to do, given that this is my probability, this is my hypothesis for the product, this is what I hope to achieve, these are my expected results. So my probability of success, I express it as the probability of this XYZ hypothesis being true. So the probability of success for my forever markers is that that it's true that at least 20% of whiteboard market buyers will buy my product. Okay, simple enough. So that's the review. So now, what is the probability of my hypothesis being true? So without knowing anything else, all you know is that I've just come up with this new product, which I've just dropped, and I'm trying to figure out, will this product succeed in the market? So what is my probability of the XYZ hypothesis being true? Well, unless I have specific data to my product, I have to use some general data, right? Data from new products. And if you've read my book and if you watch my other videos, you know that there's something called the law of market failure, which states that most new products, 80-90% of them, will fail in the market, right? So that's your starting point. Most new products will fail in the market. So because I like to be conservative in estimating the product, I would say that the probability of this marker being a success is 0.1 or equal to 10%, meaning very unlikely. So if I don't know anything, if you come to me and you say, hey, Albert, I have a new product idea, which happens to me several times each week. People come to me with ideas and they say, what do you think? I said, well, unless you can give me some very specific data of how you've tested your idea, I think your odds of success are 1 in 10. I know it's pretty depressing, but don't worry, I'm here to help you improve those odds dramatically. All right, so if you know nothing else about the market, you assume your probability of success, P of S, is 0.1 or 10%, very unlikely. We call this the prior probability. This is kind of a scientific mathematical term, so don't be scared. It means just like, what is my probability of success having no other data? So without specific data, we must assume the general probability of success for a new product. Because I don't know anything about this product, so it might as well just be a general product, okay? But clearly, that's not enough, we want to know more, right? We want to be successful. So I introduce in this lesson the concept of conditional probability. This is so important, so valuable. It may look complicated at first. It is not. It is very simple, and it will dramatically change the way you look at things and plan for your products. So the notation is this. Instead of just P of S by itself, is P of S, this sign, D. And you read it as follows. The probability, that's what P stands for, of success, that's what S. This sign, this vertical bar, you express it as given, and D. So you say, what is the probability of success given D? What is D? D is your own data. The probability of success without any of your own data is 0.1, very unlikely, because most new products fail. Unless you have data to the contrary, we must assume that. But you're going to go into the market, you're going to do experiments, you're going to collect data. So you'll be able to compute this probability of success for your product using your own data, right? And this is the key to success, right? People always ask me, hey, Alberto, you were at Google, you were hired in the early days, you were hired again. What has changed? What is the same at Google? And I tell them, look, the thing that makes companies like Google successful is very simple. They use data, data beats opinion, and they say it with numbers. Google finds a way to assign a number to pretty much anything and then use those numbers in very clever ways. And I'm going to show you the most clever ways that you can do it in this particular scenario. All right, so what we want to know is the conditional probability, the probability of success of my forever markets given some of my own data. Well, how do I get my own data? I do market experiments. So that's what my book is all about. Prototyping. How do you do market experiment? I call it prototyping. Before you spend time to actually spend $1 million to develop these reusable markers, spend a few $100s to prototype to see if the market will buy them. So here's an example of how you could prototype this product. Because your assumption, your expected result is that 20% of people will buy these markers. You take, it's a prototype called the imposter. You take a regular product, so some regular markers, and I've done it very poorly here, but you can put you can put a new cover, a new box, and you say, look, these are new, these are forever markers. You just dip them in water and they will last forever, but they cost $50, right? Because our new product costs 10 times. So the question is, will people spend 10 times the amount of money for markers that last forever? I know I would. That's why I came up with the idea, because I spend much more than that in single-use markers. So how do you do the experiment? Well, you do a prototyping experiment. You go in a place where people buy markers. Say you make an arrangement with an Office Depot, or you can even do it online. But let's do it, pretend it's in the physical store. So you make a few boxes of these markers, even though they're not actual forever markers. You just want to see if people pick them up, right? And you can learn about these prototyping techniques in some of my other videos. So, but for now, all you care about, you put it on display, and then you stand there with your little notepad, and you see of the people who buy markers, how many are willing to spend $50 for these forever markers. So that's pretty much your experiment. And let's say that, in a typical day you get 100 people, so you're there and you collect data. So you might put this list: buy, no buy. So let's look at 3 different scenarios of this experiment. And so we'll see how it works, all right? So in scenario number 1, you have 100 potential customers. They picked up your markers, they picked up the other markers, and they decided to buy one or the other. So in the first scenario, 3 people buy your forever markers. So you ask yourself, what is the probability of my forever markers being successful, given that only 3 out of 100 people bought them, right? Remember, my goal here is like 20%. I got 3%. So does my probability of success go higher or lower based on these results? Well, you would have to say it probably goes lower, right? Or it stays low at 0.1. So let's assume scenario 2. Again, you have the same setup, but in this scenario, out of 100 people, 38 people choose to buy the market. They go and say, wow, this is fantastic. This is what I ever wanted. I'll just buy them once and be done forever. I don't have to just fill the recycling bins with this stuff. So in this case, you expected to sell 20, your expected result was at least 20%, you got 38. So what is the probability of your product being successful given that 38 out of 100 people bought it? Well, it should go up, right? Should go up. They said, well, yes, most new products fail. They have a 0.1 probability of success. But with data like this, the number must go up. So for now, don't worry about, by how much it goes up. That's in the next lesson. For now, you just realize that the number must go up. Finally, let's take a third scenario. So in this scenario, still you observe 100 people, and out of this, 15 people out of 100 buy. So remember, your goal was 20%, and but you reach 15%. So what happens in this case? What is your probability of success given this one experiment in which 15 people bought it? Well, clearly, it's more encouraging than the 3 out of 100. It's much less encouraging than the 38 of 100. So does it move up? Does it go down? Does it stay at 0.1? Very unlikely. Does it move to unlikely? Does it move to likely? Right? So this is what we want to say with numbers. Eventually, we want to move from this thing, well, it looks good, looks bad. We want to be able to say it with numbers. And I'm going to give you the formula for doing that over the next couple of lessons. As a preview, it's Bayes' formula, it's Bayes' theorem. It's one of the formulas behind so much of the things that are making computers so useful today. So I look forward for that. If you have any questions, let me know. Also, if you do like these videos, you want me to make more of them, please share them, give me comments, give me likes. But so likes are nice, but I'm putting a lot of skin in the game by doing these videos. Normally people would pay tens of thousands of dollars to have me give these lectures, but you're giving it for free. And why am I doing it these days? Well, frankly, because of Corona, I cannot do this live. So I'm not gonna lie to you. I'm pretty bored and I love to teach this material because it works so well. But still, I would love it even more if you encourage me. So reshare, ask me questions, put comments, and I will see you very soon for lesson number 4, where we're going to learn how to quantify your likelihood of success based on your experiment. With that, I bid you goodbye. Have a great day. Thank you.